that. Put this over here. All right, so let's kind of address the questions so they're fresh in our mind. The videos are fresh in our minds. Kind of address the questions first, and then we're going to go into some solution for yesterday. So let us get started today. So I do have a few questions for you guys, since you were supposed to do some challenges when you watched the 3 videos. And so what is the MIME type for a mod audio file? So Andre says he has found audio/x mod, and that's one of them. There's actually an audio/mod as well. Correct, Sean? Yes. Also found one audio/mod. Yes, that's the 2 that I found as well. So those should work. I'm not sure what the difference of the X mod is, so I'll have to research that more in depth. And then the question I have, how would you add functionality to the cache to remove entries that are older than a cutoff age from the cache? And Andre says, I think you could try having a max age property on the cache and an age property on cache entries, and check for ages greater than max age when deleting or adding entries. So yes, that's probably going to work. Does anybody have any different methods that they might try with that? But that should do it in a nutshell. We have some type of timestamp. We could also probably do it where we have some type of timestamp on every cache entry and kind of order it based off of that in our cache. So the oldest item is always at the end. But a more simpler way would be to check the timestamp when the item is requested. And what's going to happen is we're going to check to see if it's at the cutoff point. If it's at the cutoff point, then we're going to go request it from disk. So if that thing in our item, how we currently have it set up, if we have a timestamp on there, we're going to check to see, is it past the cutoff age? If it is past the cutoff age, then we'll go request it from disk instead of from the cache. And so we'll just replace the disk item with the cache item. And we would do, can you think of why we would do something like this? There's a couple of use cases that you probably already noticed without really knowing what's going on when you go on a web application like Amazon Prime or Netflix, something that keeps you logged in usually, and then all of a sudden it makes you log in again. Even though you've been logged in, never had to log in again for like months, all of a sudden it wants you to log in. Can you think of why that occurs? Anybody? Token usage, clear cache. Right, you guys are on the right path there, definitely, because what's going on is most of the time there's an update. So I used to work in troubleshooting and technical support. And one of the biggest ways to help someone and they're having some type of error on an application was, hey, clear your cache and restart your browser. Usually something has changed after a certain period of time. And so that's why you would have this cutoff age, as well as why you don't have to log in every time and then all of a sudden you have to log in. Usually you'll notice that there's something changed on the website. So they're making you log in again so you get those fresh updates to avoid errors. And then applications or websites that don't force you to log in and out, you'll have these problems, and then clearing the cache and then going to the website freshly will clear most error messages. It's like one of the first troubleshooting steps to take in technical support. And so, cool. And let's see, what was the other question? Do we have another question? Any other type of cache besides LRU cache? So I'm asking this question because as I was researching some of the answers and some of the more in-depth stuff in the challenge, I found another one. And so I want to see if someone else has found that or knew it before you started Lambda. Any other type? So LRU is least, what is it? Least recently used?
Yeah. Right. I was going to say MRU was mentioned in the video.
MRU, okay.
So, I mean, I don't know if that has a use, but it might.
Any other ones? Anybody found? I found one called least frequently used, LFU. And so it's pretty much like a counter. It's like, okay, this is how many times this is used. And one fail of this, I was talking with Beach about this, and hey, what's the advantage of this? And he said, well, it can fail if we use it 1,000 times and then we don't use it for a long time, because we've used it so much in the beginning that it has this counter that's high up that tells us, okay, it's fine. And so we will keep it and probably shouldn't keep it. So LRU is preferred in that particular case. And I don't have to research MRU, but there's different caches out there. That's pretty much what I'm getting at. So this is one type of cache that we're developing. And of course, there's going to be use cases for each one of these different types. Someone sees that they have some type of problem and they're like, hey, you know what, I need to do this. And then that's how you create something else. That's how all these data structures came about, where I need something that's going to do this for me. And so one of the reasons why we combine the hash table and the double linked lists together to get the time complexity optimization that we're looking for. 1 second here, drop my pen. So cool. So some of the questions that was passed to me. Review double link list. So I will do that. So double link list review. I will do that in just a second. Can you explain MIME types? I should have probably asked this, but I'm not sure who asked that in that group. But can you be more explicit? What is it that you don't understand, or would you like to understand with that? So the purpose of a MIME type is to tell us what type of data we're working with, right? Because we have to kind of handle certain data differently. And so the purpose of it is kind of tell us, okay, this is the type of data we're going to be working with. So as we have in our cache, or not in our cache, but in our repo, we have these different types and we can handle them differently. For example, you're probably using the %s modifier, format specifier in your codes to get the index.html file to load when you go to the endpoint. However, that's not going to work for the cat image. And it's because we're telling, we have to do something different depending on the MIME type. And so that's the use case for it. Let me answer this question first. Any real applications of linked lists? So one thing that I can think of that comes to mind is a music player, right? You go forward, you can go backwards. So you pretty much have all of these music files that's linked together. And okay, I'm done listening to this song, I'm gonna click next. Or maybe I don't like this song, so I'm gonna click next. Or maybe I'm just previewing the album, so I'm gonna click next, next, next. And then, hey, you know what? A new song is started, but I really like that song that just played. So let's go back to the previous one and go to that one. So a linked list is probably used in some degree for a music player. It matches the data structure at least, you know. Can anybody else think of a use case for linked list in a real world application? Maybe. Linked list is kind of like our carousels, right? So you got an X pointer, back pointer. It's not actually structured like a linked list all the ways, but you do have this pointer to the next item in a carousel, right? And then sometimes you have this previous, or usually you'll have a previous and an X when you're working with carousels on the web, when you're building those carousels out and things like that. So I think that any case where you can think of a previous and a next would probably be a use case where a linked list is somewhat involved. You may not actually use the linked list data structure exactly, but you could probably implement one if you had a need for a next and a previous for double linked lists. So the other question here, how does my multi-part work? So I like this question because I always try to prepare myself for questions and things like that. and I didn't think of this one. So mine, the mime works pretty much where it pretty much kind of separates things out where you have two. Just a second here. It's going to send it. It's going to split the body up into separate things. So it's kind of like you have one part and then the next part. So it's going to split it up. And I got a couple of examples. I'm going to share these links as well. But I'm going to talk about this a little bit here. Is there a better data structure for a playlist style program? Oh, okay. 1 second. Let me answer that question. I've just seen that. I was away from the Flex channel. So I'm not sure if there's a better one. That question is kind of vague because everyone's going to have certain use cases for their applications. And so there's certainly going to be some other ones, but when you have this kind of next and previous, I don't think that you're going to get that from a different data structure. You're not going to get next and previous that way with those pointers set up that way. And I can't say that every playlist is set up using the linked list or the double linked list data structure. But when we think about using a next and a previous, I don't think we have another one that's going to give us this. Even a linked list is not going to give us access to the previous. It's just going to go through one time. So I think double linked list would be kind of the best one for that. I want to share this link, and then I want to share another link, and then I'll talk about multi-part a little bit more. And they actually have some pretty good examples in these. So let me share my screen real quick so I can show you these. It'll probably be better for me to show them than to type them in there. But you guys can see my screen right now, correct? Yes, okay, awesome. So it kind of talks about what it is here. So you have pretty much right here. Let's go down here. So we have multi-part mix type. And so how this works is it's going to send the different types out. So we have, both of these are going to be text plain, but where's the other one here? Maybe this isn't the one I wanted to show. This is the better one that I wanted to show. So we have this message that's sent out, and so we have multi-part / mix content type. So this tells us that we're going to get 2 parts to this thing. And then we have our first thing, then we have a body, then we have this thing, and then we have our body here. And so that's pretty much how it works, where it's going to, you can nest them. So when you have multi-parts, you can kind of nest the things, but you're going to have pretty much kind of 2 headers where you have this content type and this body and different things. So you have the first one, and then you're going to have the next one nested underneath or sent after that one. And that's pretty much how it works with multi-parts. We're going to kind of talk about how, with our application, how it works. So when we load up a web page, if there is any pictures or things in that, there's actually 2 separate GET requests. And I'm going to try to send that and make sure I remember to do that, to show you how that works. Even though we make the request once, the browser is going to actually make the request twice. So it's going to make the request for the initial HTML page, and then it's going to request anything we have inside of there. So I can show you that as well. Let me just do a quick check. Review double link list. So that's the one I haven't did yet. So double link list. What is a double link list? And I know one person probably had this question, but I think that the best way for us to learn is to teach. I think I talked about this yesterday. Even before I became a PM, I tried to help others out, and I felt like it helped my understanding a lot more. And it definitely increased my confidence to know that, hey, I'm not the only one that's struggling. And then at times, hey, I'm struggling with this, but someone else is struggling with something that I actually implemented already. So let's see if you guys can help me out with this. How does a double link work? linked list work? What time complexities? What do you know about double linked lists? What time complexities do we get for different use cases? Say to add or remove or to search. Adding is O1. Okay, cool. Search is worst case ON. Adding and removing are O1, I think. Yes, so search is ON, of course. And of course, in a double linked list, it may not be O1 if we're in the middle of the list. We can touch the head and the tail, O1 just fine. But let's say we wanted to add something in that middle of the list. So, yes, correct, Ian. So you're saying removing and search can be O1, but potentially ON. Exactly. If we want to get to the middle of the list and remove something or something like that, then we have to we have to kind of perform this for loop where we're iterating over the items. We start at the head and we work our way to the tail. And then the worst case scenario is really we go through the whole list and we don't find anything at all, right? So double link list, what provides us options so that we can have this O1 time complexity in certain cases? Cool. Certainly removing from the head or the tail, O1. If we remove from the middle, and that's one of the reasons why we have this hash table involved, so that we can get O1 removal, right? Because if we can get that without it, we wouldn't need the hash table. So the hash table is involved so that we can get O1 removal, so that we use our title as our key, and then it's going to tell us the exact pointer in the linked list to go to, and then we can go there and get our data and do it with whatever we need to do. So a double linked list has what features on it? So if we're looking at a node and we have this node, records, or maybe I should just, I already have something up, but yeah, I'll just click something real quick. New replit. So let's say we have like this node class, and this is just pseudo code. And what does a node have that helps us in the double linked list? Of course, offhand, we know it has value, right? But what else does it have? Previous and next. Yes. So we have a previous and we have a next pointer. That's what our node will have. So this is what the nodes will be in our linked list. But what is our linked list? Because our linked list, double linked list, is not actually a node, right? So what is our double linked list? It adds another linked list that starts from the tail. Okay. Head tail. Correct. So our double linked list will be some kind of, and we'll have a head, we'll have a tail, but we'll actually have like the storage of nodes, right? Well, we'll have all our nodes inside of here. So we'll have node 1, node 2, node 3, or okay, and then node 1 will likely point to the tail, the head, and node 2 will point to, or node 3 will point to the tail, right? But we have this kind of storage where it's all pointed to here, or maybe you don't even need the storage if you have it like this and you just have your head and your tail, and then you can get to the other items by going next, next, next. And we know that we've reached the end of the double linked list when and to give you a hint, if I'm going to add node 1, I'm going to say node 1, yes, when next is null. So when we initialize this thing, we're going to say node 1 has a value, dot value equals 4. And then we'll say node 1 dot next equals null. And then we might even do node 1 dot previous equals null. And then as we add node 2, well, first of all, we'll add this to the double linked list. And so we have to do some type of conditional check, right? What's the conditional check that we would do for a double linked list? As we're adding something in, there's something we have to check first. Well, we're going to get to the LRU. We're just reviewing the double linked list right now. So in this particular case, when I first set my double linked list up, I'm probably going to do, it's actually none in Python, but in C, it's going to be null. So I'm just going to stick with null because we're just pseudocoding anyway. So, and because the head is null and the tail is null, this tells me that the double linked list is empty, right? So I have to do some type of conditional check if head and tail are null, right? And then as I add this in, if they're both null, then I'm going to make head equal node 1, tail equal node 1. Now, if the head has something and the tail has something, then I'm pretty much just going to kind of add to the tail. Well, add to the tail. And how I'll add to the tail is I'll have like this temp where I'll say, well, I don't even need the temp. I just say tail.next equals node 2. And I've already, when I created my node, I would already probably do something like this. And we're going to give this a different value. And previous is going to be tail. And tail.next equals node 2. And now tail, equals no, yes, tail equals node 2. So what I've done here is, and let me update this so it makes more sense, is I have, okay, node 2 dot value equals 6, node 2 dot next equals null, which we're adding to the tail. Node 2 dot previous will equal the current tail. And so tails dot next is going to now equal node 2. And then I'll overwrite the tail and say tail equals node 2. So that's kind of how we would add to the double linked list and how we would continue on. So, and then whenever we do a search, we would start at the head, iterate until we find our value. So we're just checking. It's a linear search. So we're just checking to see if the node value equals the, or I guess we would, in our LRU cache, we would kind of search for our titles. So the value would actually be a string in this particular case. And so we would search for, so I'm going to change it to a string. We would search for this index.html until we were able to locate it. And then once we locate it, we would come out and say, okay, we can do whatever we would need to do with it. So that's kind of how a double linked list works. We're going to come back to this in more detail. I'm going to go over some solution stuff, though. But hopefully that kind of refreshes your memory on how that works. I'm going to go into solution unless there's other questions, though. Let me just take a quick attendance here. Cool. Okay. All right, cool. All right, I'm going to go into the solution then. So let me just find all my stuff here. I think that I already have it up though. That's for later. Bear with me, please. I have it up here. I just have so many files. Let's keep that up, and then let's go to reference, and we have solution for. Oh yes, I'm going to do this in VS Code. Okay, we're in the wrong place. So that is where we left off with yesterday. Cool, awesome. So let me share my screen again. And screen 2. There, you can see the VS Code, correct?
Yep.
So yesterday we kind of started off where we stated, hey, go to RSP404, copy that into here. And you'll see we still have to make some changes as I indicated yesterday, but not many changes had to be made. So we could use the existing code to our advantage. And so let's just start off by examining what is actually here, okay? So we're loading the 404 server files. We can do a quick check on this and say, okay, well, what is this server files? We can see, okay, .server files, .server root. We can come on over here. We can take a look. Server files has a 404 HTML. Makes sense, but it doesn't make sense to have something like that for our get file because we want to actually get a valid file. So let's take a look at what's available. I mentioned this yesterday. This has to be corrected in order for it to work. But we have the cat PNG and we have our index.html, and you can create a bunch of other endpoints if you wanted to. But this is basically what we needed to work. Index.html had to work. I will go over how we can get cat PNG to work, but that it was stretched. So if you don't have that working, you're fine as long as you have this. And as long as you tried your best effort and got as close as you possibly could yourself. So we're taking a look at this so I can see, all right, if I want to get my index.html file, then I'm probably going to have to use this. So what I just do is I'll copy it now. Then I'll come back down. And so the first thing that I can see that I'm going to need to change is this right here. Server root. And then there's also something else I need to change. So, oh, well, changing it in the wrong space. There we go. We're in the get file now. Server roots. And so this is something else I will have to change. What goes here? So when that is implemented here, what goes here and why? Oh, thank you, Sean. I didn't notice you, but thanks for looking out. Request path. Why? Why do we put request path here? What is the request path? We don't need this comment anymore. It will be the path. Pretty much, yes. In a nutshell here. Yes, exactly. Slash index.html. Exactly. So we're looking for our local host and our port slash something. And this should be index.html. At least that's what we're prepared to receive. And so the next step here, what I want to do actually is I'm going to do like a print statement here. So I'm going to print this out. /s/ and we just want to get a good look at this to see what it is. But so you didn't have to print this out, but this is just something you can do to test things out. So before I run my server again, I'm creating some type of error checker. So if I don't get the results that I think that I should get, let me take a look and see if file path is what I believe it should be. So this is what we're doing. This is just a way to handle potential errors that can come up. So I'm going to put this here for now. Then when I run the server, if I don't get the results that I'm looking for, I can take a look and see, okay, what is file path? Is it what I think it should be? Because a lot of times you code it and it's supposed to work, or the way we planned it out, it would work, but it doesn't sometimes. So this is just a way to kind of spot what's going on beforehand. Else we would have to run the server and then find out things don't work exactly how we want them to, and then we would have to go back and update our code, right? So this is kind of premature error handling. So here, to do, make this non-fatal. So this statement is just going to exit out. And it's saying, hey, cannot find system404 file. So this should give you a hint of what we could do here. What are we going to do in this particular case? What does a website do when it can't find the file that it's looking for? What does a web server normally do? 404 error. Okay, so this is kind of a 404 error, right? Or no? Is there something that we can use in this case instead? Do we have something like that? Yes. So Michael, this won't actually revert to the 404.html. It's just going to print this statement out. We can actually use our function that we have if we want to print that out. So now if it's null, then we'll call our 404 function, and that should get us our printout that we're looking for. Cool. And everything else should actually be set up for us. That's the only changes we had to make in get file. So what happens now? Like, are we done? Is this going to work alone? Well, one thing we can do is take an inventory, and we can, well, it's actually, if I do this get file here, otherwise serve the requested file by calling get file. If I actually search get file, that actually is a good comment there. I didn't want that though. I wanted to see where get file was called. Have we called this function anywhere? And so since we received this repo, we have to build this part out. Is it prepared to call itself? Well, yesterday we didn't get a warning stating that this function isn't completed, yet we're calling it, because there was nothing in there at the beginning of yesterday. So that should give us a hint. But also if we do a quick check, we can see, okay, the only other place that we have get file is a comments. So we're not actually calling it anywhere. And so now we're inside of our handle HTTP requests. And so we can keep our path from yesterday. We can keep that up there. And instead of handling this 404, well, we can erase that. And we know that if we don't have a file, we're automatically going to call the 404. So that's being handled for us. And if you remember yesterday, we started off with our 404. Our 404 was our friend in testing out our code. So what we can do now is we can actually call our get file, and it will handle each use case. So if it finds the file, it's going to go there. And if it doesn't find the file, then of course it's going to go to our 404. So we can update this like this. Right. Awesome. So that should get it done for us. Let's test it out. So I'm going to get the server up and running. Is this the right one? No, this is the one I did the telnet on. And all right, cool. We save so we can make. Cool. I'm going to ignore that for now. We're actually going to change that in a second, though. Let's run the server. $34.90 is the port slash. What's our path again? Index. So coming over here, I'm going to make that big. What's our path? Index.html. Where did I get the 404? So what's missing in my code that is giving us a 404? So we're calling get file. Let's go back to get file and take a look. And actually, let's take a look at the printout. Let's see what we're getting. Segmentation faults. Core dumped. Huh. What's going on? We got the request. Looks like the path / index HTML. Is that correct? We print out index.html, and then we have a segmentation fault. Missing the server root. Okay, let's see. I'm in the get file. In the printouts, missing the server root.
On your print, it's only printing the request path. It's not printing the request path with the server root at the beginning. So it couldn't find the file because it's not looking in the right folder.
Okay, so you think it's the print? Let's see.
No, it's not the print. It's the file path it's not being completed. It's just giving you the one piece. It's not adding the server root to the beginning of the request path.
It's not. Okay. So let's see. Let me see. So, okay. So it's not adding the server root. So why is it not adding the server root? Let's investigate. Let's print f file path, size of file path, request path. Am I doing this in the wrong order?
I added the formatters. It's in Slack.
%s, %s. Okay, let's try that. Awesome. Let's see. Can we make tickets. Now let's server is running. And let's go back to our web page here. Ooh, what's going on now? Segmentation, core dump. Okay. Just a second.
Your order is switched.
My order switched.
Yeah, right. The way you have it right now is put in the request path and then the server route. And I think it has to do the server route and then the request path.
Oh yeah, request path. Let's check it out. Make /server. And where's my file? Ooh, we got it this time. Whoo, nice. Excellent job, Sean. Excellent job. Awesome. So we just debugged the situation. We figured out what's going on. And let's take a look at our printout. So we're getting our printout. Looks good. Oh, no, I actually commented out my printout that time. I wanted to print out. So let me do it again. And let's get that back up. Control C, make the file, /server. And let's go to the file, refresh. It's still working. And we actually got the correct printouts, how it's formatted. So we could tell that there was a problem based off of the printouts, first of all. And then second of all, we can just troubleshoot and figure out what we need to do to add. We could have checked out this SN printf to see exactly what needs to be added to it to figure it out if I didn't actually have someone like Sean helping me. So that's how we would kind of go about debugging it. And with C, it's kind of new to us all, so you're still going to have those periods of time where you're going to have to do some debugging. So let us now work on the second part of this, which is kind of stretched, but I wanted to show you guys how to do it because I think this is a pretty cool project. So we can go to the, which file is it? Send response. We have to go handle our response a little differently. So right now, this %s is what's going to keep us from getting our cat photo. So if let's go to it right now so I can show you what it's going to look like. It's just a blank page. We're not actually getting the photo. Oh, what's going on there? And it's just basically, this is kind of like binary data. And so we have to handle binary data a little differently. So that %s is not getting us the results that we want. We're going to get the printout we want. You know, we're getting the right file path. So what's going on? It's basically just how we're building things. And so how we're building things right now, %s is not going to work for everything. So in order to work with binary data, there is 2 different ways we can go about this. That's actually, has anybody implemented this? Does anybody know one of the ways that we can go about this? Let me pull up Slack again over here. No? All right, cool. So one of the ways that we can go about this is memcopy. We can use memcopy, but I want to show that one second. So let's go over the first way. The first way is we're just going to send this thing out a couple of times. So first thing I'm going to do is I'm going to take off this %s, and then I'm going to remove the body. And cool. And I'm actually going to copy this much here and do this thing here. And so in my second here, what I want to do here is I want to just update this. So I'm going to send body and content length. Let's say that should work. I think that's the only steps that we have to take. Let me just make sure. Cool. And it's a kind of one liner to it. Well, I think it's still maybe 2 lines, but let's run this. So we're getting all types of errors. Server.c unused parameter header. Just a second. What did I just do? Ah, okay. So I kind of have to add that comma, right? Save. Make. And void get file. We're not using the cache. Cool. That's not a big deal right now for me. We're going to use that cache today. So server. And let's find that file. Should be able to get the cat picture now. So all we did was we sent twice. It's kind of similar to how we would use MIME types where you have these things nested under. Pretty much we have nested sends where, okay, we're going to send first. So we're going to send the first part of everything, and then we're going to send our actual body later. And that picture actually looks like that. Don't know why, but that's the picture they chose. So let's take a look at a different way to do this. So this way we're going to use memcopy. So when we're using memcopy, I don't need to do this here. So the memcopy way, I won't have to use that. But I still need to have the %s off of here. I still need my blank line, by the way, but I won't include the body in here. I'm going to add the body a different way. So, let's go send response. Cool. And before we get to the send, so we'll need to do this before we get to the send, is mem cpy response length. So let me explain this part first. So a response is pretty much a pointer. So we start off at the first character in that long thing. And then the response length, this is just pointer arithmetic that's going to allow us to get to the end. So we're telling it what we want to copy. And the body content length. Is there anything else? Semicolon. And those went away. This should still work. Cool. Okay. I think I want to do this as well. Because the body was not in there, so I want to update that. save, and we're gonna see if that still works. Yeah, it's already closed that, so cool. What's on? Content link undeclared. Let's see. Oh, I didn't spell it right. And make the file /server. We still should get the cat picture, so let's refresh. And we still get the cat picture. So one other thing that I want to show you guys is how this works. So I'm going to go to the index HTML, and now I want to add something to it. I'm going to add an image tag, or if I can remember this. I'm so used to it doing it for me. I don't think that I remember the image tag. Let's see, img /src equals, and so we need what? I think I can just put cat dots. Oh no, /cat. How do I have to reference this? Cat. It's in the same directory, so will that work for me? Oh, let me see, Michael. I didn't see that you posted this. Would something like this work? Vim copy, send. Yes. I think that's exactly what I just did. So that should work for you. Let me make sure I'm doing my image right. So server root files. All right, well, I'm going to test this out first. And then if I'm not doing it right, then I will. I think it's / though, right? Let's see. Let's make it and then test it out. Control C, make. It's, oh, I didn't actually change that, so it's going to be fine. Server. And then we bring it back over here, and we can go to our index, HTML. Yeah, cool. It works. So let's go over here and inspect. We want to go to network, and inside of network, where am I going in network? Boom, 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 boom. It only shows me one. That's weird. It only showed me the one. Or maybe I'm not in the correct place. Images, media, manifest. Okay, well, I tried to show you something else where how it fetches this. Control R to refresh. Let's refresh it. Yes, so there we go. That's what I want. Index.html, status 200. Cat.png, status 200. Thank you, Michael, by the way. And so why did it do two kind of gets? The one and got two things there. I just told it to do one thing this time. Thank Chrome, yeah. Thanks, Chrome. But how this works is this is gonna have a page it's loaded in, is it goes and gets certain parts. And this is kind of similar to how the multi-part type works, right? So we got our first index HTML, which is different than our cat PNG, but then we had to go get our cat PNG, and so it's kind of like a separate get here. So we kind of have multi-parts in here. So we know that this wouldn't load up if we just had the index.html MIME type or the plain text set up with our %s format specifier. It wouldn't actually work. And so it actually goes and gets the first part, and then it goes and gets that second part because it's different. So I wanted to show you guys that, especially because you had those questions regarding that. And I thought that was pretty cool. Let's go ahead and take a break. Let's be back at the 14th minute of the hour. It's strange that it's faster to load the image than the HTML. Yeah. Yeah, it is strange. There's a lot of stuff under the hood that we probably still don't know about it, but stay eager and learning, and we'll get there, I guess. But yeah, let's be back at the 14th minute of the hour. Let's take the break. Okay, welcome back. Welcome back. Welcome back. So, let me share my screen here. And I believe that I am sharing the repo right now. Let me know if I am not. But let's talk about the cache. So, LRU cache, that's what we're going to implement. Okay, we talked about what an LRU cache is yesterday. And so, can anyone tell me what is a hit, a cache miss, and a cache hit? Just reviewing yesterday before we get started. What is a cache hit and a cache miss? Cache hit is when something is in the cache. Cache miss is when something isn't in the cache. Correct, Michael. And so, what advantages does having a cache provide to us? Fast, yes. So, it compared to what? It's faster, correct, Pedro? Comparing to what? Sean, correct, disk. So, it's faster compared to the disk. So loading from disk is slower. So we have this cache to say, hey, if we've been here before, let's use this thing. And so, all right. So how do we get started with the cache? What's the first step we should do before we actually start writing or implementing our solution in code? What's the first step we should take? Step zero. What's step zero? So yes, Shine, you're correct. Check out the cache.c file. We want to take an inventory of what's here. And you could start off at the cache.h file to take a look and see, okay, we have the struct, we have a cache here, so we can see what's needed in the struct. We can also see what's needed for our cache, head tail. All right, so which one of these, so we talked about earlier today, and as we did our review for double linked lists, we talked about the double linked list and it features nodes. Which one of these would be our node, and which one of these would be the actual linked list with everything? Of course, it's named something different. We're calling it cache entry and cache. Which one would be which? Well, I guess we're kind of commenting this out as I'm looking at it, but cache is the node, and the linked list is the cache entry. Okay. I think it would be, I think this would be kind of in reverse, where this would be our node, and then this would be our double linked list, because our double linked list would have our head and our tail. But very close. And what we're doing right now is you're trying to break down the C code into things we've seen before and gain understanding based off of that. And I'm going to implement something in Python today to help with C, but it should serve as pseudocode. We're going to have to use different functions, of course, and handle things a little bit differently because Python is a different language. But I'm hoping that it will assist you with the implementation in C. Okay, so now we took a look at this file here. We can see we have a allocate entry, free entry, cache create, cache free, cache put, cache get. All right, let's take a look at C and see what's in here, the cache.c file. So we have to implement cache entry. So if I'm keeping track of things to do, I would say, okay, all right, cache entry, cool. Allocate a cache entry. So in what ways, what type of function can we use to allocate a cache entry? that should be a question. Okay, how can we allocate? So we've talked about this in intro to see when we first started. And so now you're going to be breaking it down. Okay, we have to allocate this space for a cache entry. So what is that going to look like? Or what type of function can we use to allocate this? Is this a function we're going to have to build ourselves? Or does C have a function available to us? Malloc, exactly, Michael. So right now we should be thinking, oh, I'm going to be using Malloc. We might not know exactly what the line of code is going to look like. And that doesn't matter at this point. At this point, we're just taking inventory and we're just kind of getting a heads up on everything. Okay, I'm going to have to allocate an entry. How's that going to work? Well, I probably can use Malloc in some degree. So I might even make a comment here. I'm going to use Malloc to some degree. Let's scroll down. Deallocate a cache entry. Okay, so how does deallocation work? Is this something that I'm going to have to build out, a function that I'm going to have to build out, or is this something that I can call inside of here to do that? These are the questions you have as you start to get everything going. We know it's called free entry, and it actually happens to be the free function that we can use in C to allow us to free or deallocate a cache entry. So let's take a look at this here. This is actually done for us. DLL list, insert the head. All right, cool. I can see that I have this ability to insert the head, and that's already done for me. So I can make a mental note that's okay. If I need to insert something to the head, then I can use this function. So I may make a actual note and say, okay, this is already done, but I'm going to have to use this at some point, most likely. We can begin to think of when we would use it or have to use it, or maybe we would save that for later and say, okay, you know what, I have this thing here. I'm not so sure exactly when I'm going to use this one, but it's already done for me. I don't have to do it, it's done for me. And then move a cache entry to the head of the list. And so here we're just looking at this here and we're saying, okay, here's something else that is actually done for me. Maybe I don't know exactly when I'm going to have to use this function, but it is done for me. So I can just kind of make this mental note or actual note and think, okay, I have these two functions and I'm going to have to make a decision. What's the best use case for them? Then we have this removes the tail from the list and returns it. Does not deallocate the tail. Okay. So it's telling me it's not going to deallocate the tail, but it's going to remove the tail from the list and it's going to return it to me. And so I'm able to take a look at this and I'll say, okay. So if I'm removing something from the list, I'm probably going to deallocate it at some point in time. So I'm going to probably call free or entry after I get that return. So I'll probably save the return, or maybe in my function call, whatever is returned, I'm going to call free on that or free entry on that so that I can deallocate it. Create a cache entry, create a new cache. So this right here is not done for me, but it's giving me some details. Max size is the maximum number of entries in the cache. Hash size is the hash table size. 0 for default. Okay, so I'm going to have to implement this. And so this is one of the things that I might start to probe and think, okay, how do I create the cache? I can go back to cache C and see, okay, this is what's needed, this is what's needed, this is what's needed, this is what's needed. And so now as I do that, maybe I do this. Because I like to have everything right there in front of me. So maybe I do this. And then for now, I can just comment this out. What I know that I'm going to need this for my cache. And so this gives me an idea, okay, I'm going to need this to create my cache. I know what the max size is. I know what the current size is. And so now I can think about how I'm going to set everything up in the beginning. And in the beginning, it's going to be empty. So we kind of talked about that. It's empty in the beginning, right? So we can kind of consider that as we think about how we're going to create the cache. Cache free. So this is actually done for us, where it's going to free everything in the cache. We can see free entry is being called here, right? So free entry is being called here. If I actually go back up to free entry, maybe now I know how I can implement this a little bit better because I can see how it's called. And I can see what this is doing here, and then hint, we free the cache after we free every entry. So maybe that gives me better steps to actually creating the free entry function or implementing it. And cache put. So store an entry in the cache. This will also remove the least recently used items as necessary. Doesn't check for duplicate cache entries. Okay. So I would take a look at all the parameters. Okay, I get the content type, content length, and awesome. So based off what I'm receiving here, if I go back here, it looks like I'm receiving all of these things. So cache puts here, I'm going to store entry into the cache. It looks like I'm going to have to create the cache entry first because I have all the arguments to actually create that cache entry. So, okay, cool. And then I press forward here, cache entry, retrieve an entry from the cache. So this is just retrieving the entry from the cache. And so I can think about how I can get the item and what functions we're using to get this and set things up. And so I'm kind of just probing and thinking, and I'm starting to create my plan. As I have a question immediately, there's a couple of solutions that come to mind as far as functions that I might need or things that I might do in these cases. And so I can start to write these things down and kind of start to create my plan. So the one thing that I did note is that a cache is normally set up where it's going to have this max number of bytes, but our cache is different. It's going to have a max number of entries. So normally you would have, okay, 50,000 bytes. It's going to be your max size. But our size, the size doesn't matter. We're just going to say, okay, it's going to have a max number of entries of 10. It doesn't matter what the size is. And we're doing that to just kind of make it more simple so we can get everything we want to get done and learn this concept in a week. But that's normally how it would be set up. So we would go from here. I wouldn't just take a look at the cache C. I would then take a look at server.c because we know that's where everything is done. And so we can then go and take a look at, hey, where are we using the cache? And so we can remember cache is accepted, or maybe I probably should do a search for cache. We can see that the header file is already there. You might want to do that because sometimes when you receive code from someone else, they may not include this in there. But we can see cache is used in get file. And we can say, okay, cool. And we can kind of think about how we would check the cache before we try to load the data from the disk. So right now we have something that's loading from the disk, from our saved disk. We don't actually have the cache involved. And so we can kind of think, all right, how would I go about this? Probably going to need some type of conditional. All right. I might not know exactly how the conditional is going to look right now, but I'm kind of thinking, okay, I'm going to need some type of conditional check. So we're going to check to see if it's in the cache. If the cache is empty or the cache is null, like it gives me a null return, then I'm going to try to load from the file path. And then if that is null, then it just doesn't exist. We can do our 404. So now I'm kind of creating my plan. Boom, boom, boom. Step 1, step 2, step 3. And we can continue our inventory and do HTTP requests. And so we can see cache is used here somewhere. We kind of voided it out right now. But we can start to begin to think of how we're going to use this in the HTTP request here. And so right now we're calling get file and we're passing null. And if we go back to get file, we can see that second parameter. Okay, so I'm going to have to update that because that's where my cache should go. it shouldn't be null anymore once I get this implemented, right? So this is just a walkthrough of how you can kind of take inventory and how you can start the probe. And again, if there's a question that you cannot answer, then this is where you would use your resources. And it's requested that you use the PM resource first before you go to Google. And we might Google together or something like that. But use the resources, probe, think about what you're doing. You either have the implementation or you have questions on how you can get your implementation. So let's slow that down. And I'm still sharing, but let me grab my live project that we're going to do. And let us. So in order to get a high level understanding of what we're trying to achieve with caching in the web server, we're going to implement the same type of cache in Python. And it was actually funny today. I went to the meeting where we get with each PM gets with their group and they ask questions before the lecture. And one of the individuals in my group kind of was ahead of me on this one. His question was the question I was going to propose to you guys, but we're going to get to it and we're going to see if someone can answer it. And if no one can, then I will answer it. So, but let's get the LRU cache implemented here. So how is this going to work? So let's take a quick inventory of what we have here. We have our doubly linked lists. For those who already completed the lab, okay. So we kind of already have the doubly linked list built out for us here. We can see previous value, next, and we're looking at this and we're saying, all right, cool. And we can see comments about everything. So I'm going to share this code with you guys so that you can get an understanding of how this works. But we've pretty much already did a double linked list in Python, if I'm not mistaken. So I'm not going to go into this too much, but we can take inventory of what is here real quick before we get to insert after, insert before, delete. We have our double linked list class. We have our add head, remove from head, current head, add the tail, move from tail. All right, move the front, move the end. Cool. And so I'm going to come over here and implement this thing out. So we're going to implement the constructor for the LRU cache class. And can someone tell me for our LRU cache, what is the data structures that we're going to be using for our implementation? There's two of them. What two data structures are we using that we can? Yes, a hash table and a linked list, correct. So let's get this first part up and running. So it's a double linked list, right? Correct. It's going to be a double linked list, correct. And that's what's going to help us get the O1 operation in for everything we need. And all right, cool. So self dot, actually I don't know. Okay, there we go. Self dot limit equals limit. Self dot size equals 0. Self dot order equals doubly linked list, and self dot storage equals just a regular dictionary here. And my class. So Python doesn't have the curly braces, but I like to put this point here to let me know when I've ended a class. I'm getting this expected indent block. let's move forward. So the next step here is implement the get method for our cache class. So our get method here, we're going to need to check if our key is in storage. So this is our hash table portion. So let me make sure I give you guys some good comments on this. No, that is not a Python comment. Spelled limits. Oh, thank you. I didn't notice that. Appreciate that. So let's go in here and let's do this. So the first step here is we want, using C comments, we want to check if the key is in the storage. If key in self.storage, then we're going to say node equals self.storage key. And then here, we're going to use one of the functions where we're going to move to the end. So we're pretty much going to add this to the end. And the reason why we're adding it to the end is we want the least recently used. And so anytime we use one of the things in our cache, it automatically is going to move to the end. All right. So it doesn't matter if we haven't reached the limit of our cache, we want to put it at the end to represent the least recently used. So or 1 second, I'm saying that wrong. We want to move it to the end. Self.order.move to end node. And we're going to return node.value 1 else return none, which is pretty much that key doesn't exist. So we're trying to get something that doesn't exist. And we're going to end this function. And what is next? So we want to implement the put function. So sets the given key value pair as the new tail of self.order. Also adds the key value pair to the self.storage if self.order is already holding the max number of pairs. The head of self.order will need to be evicted before the new key value pair is added. Lastly, if the key already exists in the cache, the old value of the key should be updated, and the newly updated key value pair should then be moved to the end of self.order. Should be an O1 operation. All right, cool. And these comments, though we're writing in a different language, it's going to help you when you're updating your own cache in C today. So we want to put key in self.storage. We need it to be in there. Node equals self.storage key. Node.value equals key, comma, value. All right. And this is why we return. I have another error. This is why we return 1 here, because of the way we're going to put it in here. So it's a tuple, and this is going to be the 0 index. This is going to be the 1 index. And self.order.move to end node return. And now we need to do a check on our size versus the limit. So if self.size equals self.limit, we can delete using the L. Of course, in C, we would have the 3, most likely. So immediately right now, you can associate deleting something with maybe a removal function, and most likely the free is involved. Dot head dot value 0 self dot order dot remove from head self dot size minus equals 1. And this is going to be end of my condition. And the reason I put that comment there, I can just tab over, but I like to just do that there for my own eye. Tail. We're going to make that on the tail. Self.storage. Key with self.order.tail. Self.size plus equals 1. All right, and the reason why we do self.size plus equals 1 is because that remove is going to minus equals 1. So, and now I'm going to do this and the put function. And let's see, we should be ready to go, but I'm getting an error message here. And let me see, format documents. This is called expected an indent block. Why did it expect the indent block? Let me refresh. All right, cool. So I already have some data here. Let's run it. Let's see. That's no attribute put. So dot put. Oh, I see. I didn't have this stuff in my class, so I should not be ending my class right now. All right, I got you. I got you. There, and I have my output there. Cool. So we kind of use the similar phrases that you are used to that you're going to be working with today to implement this in here, to have a key and a value. And so we're going to put them in and we're going to get them out. And then here's the question that came up earlier today. So this is using collections.ordered dictionary. And we're going to do things a little differently, but we're going to use the collections.ordered dictionary. We have our gets functionality. We have our put functionality here. And so the question that was asked was, I think we had to do LRU cache as a stretch, and they used the order dictionary from Python, imported from collections here. And the question was asked, what's the disadvantage or advantage? And so let's go to this here and pull it up. So if we go to Python's collection, and I like Python because of the different things, how they spell things out. They even show you how things are set up. But if we actually dig deep under the hood of the order dictionary, they're using a doubly linked list to keep track of the order. So in Python, this would be more Pythonic to use the collections.ordered dictionary because it comes with things already done for us, so we don't have to do all of this. But behind the scenes, they pretty much are already doing all of this. So the time complexity and things like that wouldn't actually change. It's just underneath the hood. The order dictionary is actually providing us linked list behavior to keep the order, and then it also gives us access to this hash table, which is a dictionary in Python. So I said I would address that later, and this is it. I already had this part, so but that is pretty much how it works for the double linked list. Hopefully this was a refresher on double linked list. Hopefully these comments and this code actually helps you in the implementation of your project today. And I'm going to share this right now. Good deal. Does anybody have any questions from what we talked about, or maybe a question that I missed that I didn't address? Cool. Well, if no one has any questions, I'll let you guys do a quick inventory before you start lunch. And after lunch, then, try to create your plan. I have questions concerning reaching MVP for yesterday. Will there be a QA for today? I have not been told that there will be a QA just yet. But once I know, I will let you know. And then I will even reach out and see if I can get an answer for you about that. So once I figure that out, then I will post it in the Flex channel. Any other questions? And then you have questions concerning reaching MVP. Are you trying to figure out what was MVP yesterday? Because I believe it was pretty much getting that get file to work, being able to go to the index.html endpoint, being able to get the cat picture to work was stretch. So, but if you could get to the endpoints index.html yesterday, then I would say you were caught up. Well, Michael, we actually have 12 minutes if you want. I mean, if anybody wants to drop off, they can drop off. But if you want, you can share your code and we can kind of debug over the next 12 minutes if you want. You can leave that to you for an option. That way, after lunch, you can take care of today's work.
No, that sounds awesome. I'd really appreciate that.
All right, cool. Let's unshare on my end. Cool. Let's see what you got.
Okay. So let's go to server C. So I got the send response set up correctly, I believe. I don't think I need line 66, but I noticed that you included that.
Okay, yeah, we're just updating the length because we are copying more over into it. So
I believe I'm doing it within the RV when I initialize the RV right here.
Oh yeah. You I don't think you need that. Yeah. Correct.
Yeah. Okay. Cool. I wanted to confirm that, and right now I'm not sure what I'm missing because this project just kind of baffles me. There's a lot of moving parts, as mostly they all are. So I'm pretty sure I got the 404. Like that should be good. Shouldn't have to do anything except for making it non-fatal. I need to do that. But I got all this from today's lecture.
Well, the 404 was kind of done for us in the.
Yeah.
So I think the get file is where we want to be.
Yeah, that's what I meant. I'm sorry. Yeah. So I'm not sure what the get. I know what the get file does. It's self-explanatory. I just need to look over it and figure out exactly
so
how it works.
One thing that I'm looking at is line 152. Mm-hmm. We don't need that anymore because we're going to call the 404 function.
Yeah.
Okay. And you have a good test print in there. So what are you getting? I think you deleted a little bit more than you wanted.
Oh, did I really? Oh, just the 404? Okay.
No, you can keep the 404. We can get rid of the exit 3.
Oh, okay, gotcha. Let's see. Will it make? It will not currently make. I was trying to do the handle HTTP request, and that's where I've kind of fallen off. I haven't gotten this far yet.
Okay, handle HTTP requests. So there's a problem there. Can you scroll over that path? What's wrong with that?
Sure. It's not defined yet.
Oh, okay. So we'll need to define that.
Yep.
So, I guess I won't ask you to remember that because it probably would already have it. But so we pretty much need an array.
Okay,
We need
so
2 arrays. We need an array for our method and an array for our path.
initialize 2 arrays for the method and path.
Right. And let's see.
Oh, is that already?
I don't think you're doing that part. So the method is going to be our get or post, and then our path is the /index.html. Let's go ahead and put 512 in our method. 512.
Sure. Oh,
And then in our path, let's put 8192. Give us enough space. There's a way to have your function work with arbitrary sizes, but we're just going to do this for now for simplicity purposes.
sure.
And to do that would be stretch anyway. So
I'm just worried about getting MVP right now, so
right.
I can working today.
Cool. So 192. Read the 3 components of the first request. Let's go to 193. So do you remember how we can parse the data?
It was in the README, I think. I don't remember off the top of my head.
scanf.
scanf,
Mhm.
gotcha. So scanf, what does that do?
scanf is going to parse our data. So when we get this space or new line, we're going to break off. And so we can put our method and path in as arguments at the end, but we would put our request in the beginning. So the request is what we're going to parse. So line 178 is giving you a request. So our first argument, scanf, please.
178. Okay, so scanf. What were you saying? Sorry.
So line 178 is getting our request.
Mm-hmm.
And so now we can put request in as our arguments. Request should be updated.
Oh, okay.
So that's our first argument.
So you said.
And if you remember how we just did, what file was that we were doing? The get file. We were using sprintf. So we kind of set it up similar where we have to use the 2 format specifiers, %s.
Okay, yeah.
But we're going to separate each format specifier with a space. But we'll have 1 string, %s, space, %s. And then now we can comma. So now we're prepared to have 2 arguments. So the 2 arguments you would have, what would those be? And in what order should they be?
So we're trying to parse the file descriptor, I think, to get the header from it, to be able to get the file.
Actually, we won't be using the file descriptor, but we just made 2 arrays.
Oh, okay.
We need to be parsing.
Oh, is there anything in there to parse?
Well, so what we're doing with scanf is we're going to parse requests, and then we're going to put
them
information to our method in our path.
Okay. So it depends on how I'm sending the data in the request.
So you're getting the data in the request, and in the request, if you remember yesterday or the day before, how we get information, what's going to be first, the method or the path? What comes first?
I would assume generally the method comes first.
Okay, yes. So the method and then path. So we're getting that. Awesome. And if you want, you can print that out, and I'll provide you with a printout very quick.
Oh, sure. Thank you.
Just for debug purposes.
Yeah.
And cool. So now your path is actually something. And let's try to run. Let's try to do something.
Okay, it makes Okay. Having trouble because I'm going to 1, but we want to try to hit index. Is that right?
Yes.
Okay, so unable to connect.
Unable to connect.
Oh, seg fault, server root. Oh, because it died before it even was able to try. Okay, so the connection was reset whenever I tried to restart it. And got request get HTML, and then it points me to server root index.html.
Okay. And but we're still not getting index.html.
Does it matter that it spams it like I guess 8 times or whatever?
Yeah, that's kind of weird. What type of
Yeah.
computer are you using?
Actually just switched. I'm on an Ubuntu laptop right now.
Okay. So Sean is saying your Git file still needs a send. So have we done that?
Send.
Our Git file. Let's go to Git file. Function.
No.
Oh, okay. So here we haven't called the send response. So if everything is okay, then we need to kind of proceed. Can you go to the 404 file?
Sure.
Function, I'm sorry.
There you go.
So your send response is going to look a lot like that. We can actually have 123, 125, 127. Let's copy that over to your Git file.
Ooh, under the conditional?
Mm-hmm.
Sure thing.
And we'll just need to change this up a little bit. So we're not going to do a 404. We're going to do a line 156.
156. Oh, right here. So it would. Is this hard coded?
Mm-hmm. Go ahead.
Okay, so it'd be 200. Is there anything else I need to add
And then we
there?
usually do okay, space okay.
Oh, okay. There we are.
And everything else should be there. So let's save this and then let's make it again.
Really? Okay.
And that may be the reason why it's doing what it was doing several times.
Yeah.
I didn't notice that you didn't have the send response in there.
Having trouble finding the site. Seg fault.
Seg fault. Server roots / index.html. That looks good.
It should have a dot in front of it like that. I assume so, but
fd http /1.1 space 200. Okay. MIME type file data file data size file free file data. Okay. Where is your file data equals file underscore load? That looks good. Percent as server root request path.
can you see everything?
Are we getting our printout of our path? I'm sorry, go ahead.
I was asking, can you see everything fine? Is it large enough?
Yes,
Okay.
I can see it.
You said, are we getting our printout?
Yes, I think we are getting the printout.
Yeah.
It's going to be that second line, server root index HTML. So
Yeah.
what is it defaulting at? So can you put a printout on line 155? No, yeah, 155. Just print out anything.
So just anything?
Yep.
Okay.
And then on line 57, print out something for me as well. Whichever line doesn't trigger, then that's normal. And it might be our send response, but I definitely want to show you how to kind of debug this.
Okay. So it's not one
here. So it's not getting to line 157. So let's go to our send response.
Okay. Whoops. I did do that. There we go.
And let's take a look. So let's make sure the build is good. Can you do SN printf for me? I know we talked about sprintf, but SN printf is a little bit more secure. But let's do SN printf.
Also, I just copied your formatting today. I had it differently, just a quick fix. I just noticed.
No, we don't need the content length there. Yeah, we should have header as the first one, content length, and then content type. Or yes, so content length should be your second.
Oh yeah, true. So content length, content type. Yeah, that should be good.
Okay. And if you want, you can try to run that and see if that was it, but I'm still looking. So
yeah, well, yeah.
there we go.
We got the home page running. Sends back a lot of debug prints. That's good. All right, so and this should support cat.png. Cat.
Did you change it to .png yet?
I did. Contains errors.
Cannot be displayed because it contains errors.
Oh, server. Yeah.
Oh, okay, so you did change it to .png. So let's see. What's wrong with that? So
What's that under?
Response plus. No, it's going to be in the send response, I believe.
Send response. Okay.
So we have that set up. Response plus response dot response underscore length, body content length, and then response plus content. Yeah, that's that one's weird. I mean, the only difference that I can see between what I did this morning is that I just did response length plus equals content length. But let me take a deeper look at it because I don't think that should cause the problem.
Sure. I can change that for right now just to see if it is.
And then you'll have to update the
right here. Right? Oh.
What the
Oh, there it goes.
It's going away. Okay, cool.
It takes a
I
second. That probably won't work, but worth a shot.
Yeah, why does the PNG not work? Response PNG. Huh, that's very weird. Can you DM me this code? And I'll look at it. But it's stretched, so as long as we can get to a file right now, I think that's pretty good. But I will take a look at it.
I appreciate it, Jonathan. Got me to MVP.
Cool. Yeah, let me take a look at this. I'm gonna go to lunch and then I'll take a look at it and see what I can discover with it. There's got to be something really, really small going on there. All right, cool. Anything else? Anybody else? I think we're last few people in here. Cool. Well, thanks for joining, and you guys have a great day. And Michael, if you DM me that, yeah, I just got it.
Awesome.
I'll get that for you. All right. Cool. Have a great day, everybody.
See you.